Welcome to Lesson 2.3, Reusable Code, Functions. In the world of software development, efficiency and clarity are paramount. Imagine you're building a complex application, and you find yourself writing the same set of instructions over and over again. Not only is this time-consuming, but it also makes your code harder to read, maintain, and debug. This is where functions come in, acting as powerful tools to streamline your development process. By the end of this lesson, you will be able to define what a function is and understand its core purpose in programming. We'll explore how to effectively create and call functions, passing in necessary information and getting results back. You'll grasp the critical concept of code reusability and learn why the don't repeat yourself or dry principle is so vital for building robust and scalable systems. Finally, you'll gain practical experience in refactoring existing code to leverage functions, making your programs cleaner and more efficient. Let's dive in. Let's start with an analogy. Think of functions as sub-recipes in a larger cookbook. When you're making a complex meal, like a multi-course dinner, you don't write out the instructions for chopping onions or making a basic sauce every single time they're needed in different dishes. Instead, you have a separate, clearly defined sub-recipe for each of those common tasks. In programming, a function is exactly that, a named block of code designed to perform a specific, well-defined task. It's a way to encapsulate a sequence of operations into a single, callable unit. The primary purpose is to organize your code, breaking down large, complex problems into smaller, more manageable pieces. This modularity makes your code easier to understand, test, and maintain. Just like a sub-recipe ensures consistent results for a specific component of your meal, a function ensures consistent behavior for a specific task within your program, regardless of where or when it's called. Now, let's look at how we actually create and use these sub-recipes or functions in our code. Defining a function involves giving it a name and specifying what information it needs to do its job. These are called arguments or parameters. Think of arguments as the ingredients your sub-recipe needs, like amount of flour or type of vegetable. Once defined, you can call or invoke the function whenever you need that specific task performed. You pass in the actual values for the arguments, and the function executes its block of code. Often, a function will then produce a result, which it returns back to the part of the code that called it. This returned value is like the finished dish from your sub-recipe, ready to be used in the main meal. This mechanism is fundamental to avoiding repetition and building flexible, efficient programs. One of the most crucial principles in software development is dry, don't repeat yourself. This principle advocates for reducing repetition of software patterns, replacing them with abstractions, or, in our case, functions. Imagine an e-commerce platform where you calculate sales tax in 5 different places in your code. If the tax rate changes, you'd have to update all 5 locations. This is not only tedious, but highly prone to errors. By encapsulating that sales tax calculation into a single function, you define it once and reuse it everywhere. This dramatically improves maintainability, as any changes only need to be made in one place. It also enhances readability, making your code easier to understand because the intent of a function call is clearer than a block of repeated logic. Furthermore, it boosts scalability because you're building a system with well-defined, independent components that can be reused across different features or even different projects, leading to more robust and efficient software. Let's put this into practice. Imagine we have a script for an online course platform that applies discounts. Initially, you might have the discount logic copied and pasted in various places, when a user enrolls, when they upgrade their subscription, or during a seasonal promotion. This is a classic dry violation. Our goal is to refactor this script. We'll identify the repeated discount calculation logic and encapsulate it within a single function, let's call it calculate discount price. This function will take the original price as an argument and return the discounted price. Tools like GitHub Copilot can be incredibly helpful here. As you start defining your function's signature, Copilot can often suggest the internal logic based on the surrounding code, accelerating your refactoring process. By doing this, we transform repetitive, error-prone code into a clean, reusable function. This not only makes our script more elegant, but also far easier to manage if the discount rules ever change, proving the real-world impact of functions. We've covered a lot today. We started by understanding that functions are like sub-recipes, encapsulating specific tasks to make our code modular and organized. We then explored the mechanics of defining functions, passing arguments, and returning values, which are essential for creating flexible code. We emphasized the critical "don't repeat yourself" principle, realizing how functions drastically improve maintainability, readability, and scalability. Finally, we looked at a practical example of refactoring, turning repetitive code into a clean, reusable function. Now it's your turn to apply what you've learned. The best way to solidify your understanding is through practice. Can you create two functions, one that takes two numbers and returns their sum, and another that takes a name and returns a personalized greeting? Then, call both functions in your script and observe their output. This hands-on exercise will help you master the core concepts of functions and set you on the path to writing more efficient and elegant code. What are the key benefits you anticipate